Hi, welcome, and thanks for joining us on this webinar today. My name is Ed Dawson-Taylor, and we're going to be talking about Houdini fundamentals for generalists and how to learn it the simpler way. Before we do that, though, I just wanted to take a second and talk about CG Pro. CG Pro is an online school or an Unreal Authorized training center founded by industry veterans with a commitment to lifelong learning and the accomplishment of big goals. We're one of only 9 schools worldwide teaching the upcoming Epic Connectors program. All classes are taught 100% live by leading industry supervisors and instructors. In full disclosure, there will be a paid offer at the end of this content, but stick around to the end and we'll go over how you could come study with us, why you should choose CG Pro, and why our students go on to work at great studios like ILM and MPC. Also, our next Houdini class is coming up on June 9th, and there's still some spaces available. So if you're tired of trying to figure it all out by yourself, or you can't wait any longer to learn the best, most exciting, most powerful 3D software there is in the world, then give us a call. Again, my name's Ed Dawson-Taylor, CG Supervisor, Unreal Authorized Instructor, and the Head of School. I hope you enjoy this webinar. So a little bit about myself to start with. Been in the visual effects industry for about the last 15 years. I've been a CG supervisor and I've been lucky enough to work on some really cool movies like Jungle Book and Jurassic World and The Lion King at some cool studios like Industrial Light and Magic, NPC, and Digital Domain. I'm a teacher, instructor, Unreal Authorized Instructor. I also am the founder of CG Pro. So I want to start off talking a little bit about why learn Houdini. Probably a lot of people know Houdini as an effects heavy package, which it is. It's where it comes from. It's extremely good at doing really complex effects in the movies and other industries as well. But it's becoming a really powerful tool for generalists as well. And this is what today's going to be mostly focused on. I just wanted to bring up some cool examples of things that can be done in Houdini. So on top of the effects work, there's lots of really amazing stuff that you can do in building cities. The recent Matrix demo from Epic is a great example of that. That whole thing was laid out procedurally using Houdini. Um, and yeah, just really an amazing package if you want to be able to turbocharge your workflow. That means being able to do more quicker, which is great in terms of your own productivity and your own value as an artist. It's amazing to be able to be more productive. This really helps you to do that. To be able to punch above your weight, be able to do more things, and effectively model a pipeline with an individual. You can do so much with it. It's so powerful that you can actually basically be a one-person studio. And who is it for? So, as I said before, it used to be mostly in the domain of effects artists. It still is used primarily, probably the most powerful tool used in effects today for simulating cloth and fluids and crazy particle effects and pyro and explosions, all kinds of cool stuff. But becoming used more and more by CG generalists to be able to do modeling complex things that would take forever to do by hand, being able to process tons of geometry, moving into some really interesting things that we'll talk about today. Also being used a lot by layout artists. More and more studios are getting very interested in using Houdini for doing layout and lighting, look development as well. And it has some really fantastic tools for working with USD, which we will talk about as well. Also, as I said, lighting artists, and it's becoming really powerful for working with motion, rigging, animating, processing mocap. Motion kit bashing is becoming a term where you can, like geometry kit bashing, where you can put models together, motion kit bashing to be able to put motion together, and something that was really only done in Motion Builder before, but now this is becoming a really great option for doing that as well. So I'm going to go through briefly what this session is about. So the 5 fundamentals of Houdini for generalists. We're going to go a little bit into the fundamental concepts, the foundational concepts of what Houdini is, how it works. We're going to talk about modeling and how to create terrain and how to process geometry, how to procedurally model things. We're then going to talk a little bit about USD, which is becoming the industry standard for interchange of geometry and scenes. And we're going to talk about motion, talk about kine effects. We're going to talk a little bit about motion kit bashing, and then we're going to talk a bit about effects, and not in the complex, daunting approach to effects that has been the way in the past. We're going to talk about Vellum, which is a kind of simpler entry point to working with effects as a generalist. And what is not quite as much, as I said, it's not really a deep dive for effects artists. It's not going to be a heavy effects kind of webinar. And it's more of a tour than a tutorial. So we're going to be going through ideas. We're going to be showing you a few things. But yeah, let's get started. So what do you need to be able to use Houdini? You need the hardware. Obviously, you need for crazy high-powered effects, you need a really powerful machine. For generalism, you don't need quite as much procedural modeling. It benefits from having more power, but doesn't need quite as much. The software, amazing people at Side Effects have made it available for free with Houdini Apprentice. So you can learn for free, and Houdini Indie, which is very affordable. It's in the hundreds of dollars range as opposed to thousands. As long as you meet the requirements for that, you can use that commercially with almost no restrictions. And then you also need the skills. So as I said, learning Houdini can be scary. The idea of this is to show you that it doesn't have to be. And though there's an entry point now, which part due to the tool kind of coming of age, I guess, they've added some more user experience to it. It's becoming easier to learn, and it's a great time to learn it, in my opinion. So just briefly, I'm going to talk a little bit about proceduralism, because it's important to understand what that is if you want to get into how Houdini works. Okay, so the old way, using the DCC, the old approach to modeling something or creating something, is a manual one. So the good thing about that is that it's kind of easier to work with more destructive processes like modeling and animation and those kinds of things. The cons are that you have to manually do everything. So with this approach, you have to create everything by hand, which obviously takes a lot of time, and the operations that you're doing are destructive. They are irreversible. You have to save versions constantly to be able to go back to stages in your process. So that's obviously not very flexible, and making changes to objects created in this way usually means going back to basics, going back to scratch. And manual variations are all built manually. So the alternative approach is proceduralism, and this is what Houdini is built on, and it's absolutely religious about sticking to that ideal. And this is about creating recipes to make things as opposed to actually creating the things manually. So the great thing about that is if you want to recreate it, you just have to tweak the recipe and let Houdini do the rest. The disadvantage there is that it's not quite as good at doing destructive processes, destructive modeling and that kind of thing. It's possible, but not quite as good at doing that. It's also got a relatively steep learning curve. That's something which I dedicate myself to helping people with, but it is tricky to learn, especially by yourself. So just to simplify the idea of it, essentially you have some data, you have a model or some information as your input. You pass it through a processing function which processes it or changes it, and then you get some output. And that is really all that is going on here. Just to make it super simple, it is just feeding information into something, changing it, and then pushing it back out the other end. And a recipe is something that takes something in and does something and pushes it out. So it's effectively the same as a recipe. The great thing is there that recipes are reusable, adjustable, customizable. You can change them, extend them, share them, adjust them. A quick overview now of what we're going to go through. So, as I said, we're going to touch on Houdini fundamentals, how it works. We're going to go a little bit into some modeling concepts, talk about modeling complex objects that would take a long time by hand, doing some layout and terrain generation. We're going to go into USD, talk a little about layout and lighting, and the fact that probably the best editor for USD that's out there at the moment. We'll talk a bit about motion. We're going to display some procedural rigging concepts and some motion processing. Talk about some of the things like mocap and cleanup and retargeting, those kinds of ideas. And then just touch on effects as well, a simpler way to get into effects using Houdini. So to start off with, Houdini fundamentals. All right. So you've all probably seen giant node graphs like this that look scary. Don't worry. We're simplifying this idea, as I said, just by taking it one small step at a time. And the idea here is that we've got data and it's flowing through a graph. And as it flows through the graph, we do things to it. So we've got inputs, they're processed into outputs. That is all it's doing. So just take one little node at a time. That's all it's doing. And this idea of cooking, as it's a recipe, the recipe needs to be cooked. And Houdini is responsible for cooking all of that information through the graph. And the great thing here with the spreadsheet that's on display in the bottom right here is that you can inspect all of the information at each stage of this process. You can check it out, see what's happened to it, and it becomes really easy to debug. I know it looks like a bunch of nodes and numbers, but honestly, it can become comfortable very quickly if you kind of know the approach of how to look at it, how to build things up slowly. I used to be a software engineer, so I kind of get this anyway, and I bring what I know from that world into this as an engineer, applying this. I've also spent years now being an artist, so bringing those two parts of myself together, I could understand how to apply the principles of engineering through this tool, which allows you to iterate really, really quickly and make changes. And as I said before, punch above your weight, be able to do a lot more in less time. So, yeah, as I said, this makes it really, really easy to inspect what's going on and understand it. So within Houdini, we've got the idea of operators and context without overcomplicating it. The idea of these contexts is that you're doing different kinds of things, different types of work. There are contexts for each of those types of work. The major context you're probably going to spend most of your time in is SOPs. This is surface operators, things that work on geometry, basically. There are others. So SOPs is a great place to play if you're working on geometry. The object context is where you're going to have actual objects. If you're similar to having objects with transforms in Maya, for example, you could be in the object context. In the object context, you will be jumping into an object, and in that you'll be in this kind of soup of points, as we showed just now. So this will all make sense in a second as we jump into it. But the idea of contexts is we're jumping between types of work. There are the context for USD, and LOPS is its name, or lighting operators. That's a place where you're going to be working on USD. It's a very powerful tool for working on USD. Motion, where previously that may have been in a different context, chops. Motion is now, to do with characters at least, handled in SOPs. So we're treating basically joints and skeletons as geometry, which is kind of crazy if you think about it, but very, very effective. And the great thing there is that you can apply all of the processing that you can do to geometry to motion, which brings up thousands of nodes within Houdini that you can use. So effects, again, before we would have been jumping into DOPS to do more complex effects. A Vellum can actually live within SOPs and kind of simplifies. So most of it now can be accomplished in SOPs. And that kind of simplifies things, I think, a bit. From Where it was before, where it was more really complex, you have to jump through between contexts all the time. Now it's becoming much easier to stay in one place. And there's a whole bunch of others if you want to do work on tasks. That's basically using Houdini to be a pipeline and allowing you to fire off tasks that could be modeling something and sending it to a compositor and bringing it back and doing all kinds of things that aren't even Houdini. It will run those things for you, and you can build a really cool pipeline by yourself to do all kinds of work, which is really, really powerful. And then context for working on materials and effects and compositing, all kinds of other things as well. So jumping into modeling and layout in SOPs. So this idea here with SOPs is, if I just bring up Houdini for a second. So here we go. So let me just go back up here for a second. So this context is, you'll see this little context drop down here. So for in the OBJ context, we have these nodes here. These are geometry nodes. These are kind of like objects in Maya, for example. You can parent them together. You can connect them in hierarchy like that. They have a transform up here. So it's kind of like an object that you might be familiar with in another program. But as soon as you jump into one of these nodes, you're now in SOPs. And now you're in this kind of soup of geometric data, basically. And this becomes like you're inside a shape node, but a shape node that you can program, basically, to do what you want it to do. So as I showed earlier, we've got this really simple idea of a very simple chain here, very simple chain of nodes. So to start with, a grid, and then we apply, so this is our input. We then apply a function to it, this mountain SOP, that adds some noise in height. So now we have basically a mountain range. And then we go to our output, and this null is just kind of a place to access that information again. So very, very, very simple idea, just to not overcomplicate it before we move on. But that is our SOPs context. So very, very quick. And with all of these nodes, if I bring up the properties for the nodes here, so the parameters here allow me to be able to change pieces of the recipe, basically. So I can change the height, the amplitude there. I can change the size of the noise, and it all happens really fast because Houdini is so fast and powerful that you can do all of this stuff. You can process tons and tons of geometry really in real time, basically. So very, very powerful. So with our modeling and layout that we can do in SOPs, we're thinking of this as a soup of points. No, this spreadsheet down here indicates that you're able to see all of these points. So all the points that we're manipulating, if I just bring one up here, we can click on the spreadsheet for our grid here. With this, you'll be able to see all the points in the grid like that. And then if I want to see where those points are, you can see that they've got zeros for the height. If I go to our mountain and I do a spreadsheet on that one, now you'll see that the height is being affected. So we've got some more some changes in the information there. So this just allows you to be able to see what's happening to all the positions of the points. And that's very, very, very helpful when you're debugging what's going on. When your node networks get a bit more complex, super useful to be able to do that. So yeah, as I said, everything is points and attributes. The attributes, as I just showed you in the spreadsheet there, you've got position, that's an attribute. Where that point is an attribute. You can also have all kinds of other attributes like color, for example. If I wanted to bring this back in here, I can have this little attribute randomize at the bottom. If I click on that, now this attribute randomize here is working on our color attribute, and this just basically added a random color to each point. So as you can see there, it's become this kind of psychedelic landscape now because we've added a color attribute to each point. And this, I could have randomized any attribute there, but if I click on the spreadsheet now, you will see that I've got, in addition, my position, which I had before, and then also the color attribute. So everything is some version of this from now on. So a very, very, very simple idea just to think of it as points and attributes. And if you change those attributes over time, then you have animation and you can record that animation and render it. And yeah, Houdini is extremely good at doing all of this. So before I jump into USD, I just wanted to show another couple of examples here. So if I jump back into our graph here, I've got some simple examples. One I wanted to show you very quickly was just this UFO, which I did for a recent tutorial. And my UFO began its life as a sphere, very, very simple. I then put a simple transform onto it, so it basically squished it into the shape of a UFO like that. I then used a labs tool, which is a group of tools made by side effects. They're not core tools, but they're kind of added on top to simplify the workflow. They're kind of wrappers to a lot of the base level nodes. So these simplify what is going on a little bit more. So stepping through here, as you can see, this is subdivided all of the geometry into more detail there. So you can see we've got more detail on top of it. I then added a attribute randomize for a new parameter. I'm going to push these little bits in and out, but I want them to push them in and out by a different amount. So because of that, I need to randomize that value all over this surface so that each of those pieces has a different value. And I get to see it just by checking here on my attribute randomize, which I just click on spreadsheet here. I'll now see that for my, I did these on the primitives, not on the points. So as you can see here, I've got my Z scale there. So this column has random numbers, and that's going to drive how much these bits are pushed in and out. And I then go on to randomly select some of those so that we're not selecting all of them and add them to a group. I can colorize it so you can see it's just selecting some of them. And then I'm going to run my extrude, and my extrude is going to pick up my random scale value. So you can see here that in local control, we have Z scale, and that is the attribute that I randomized up here. It's randomized the Z scale attribute. So my poly extrude, it's going to do it by the amount that I set with that variable. As you can see, it's different all over. Some of them are going further than others. And it's only doing it to the ones I selected. I didn't want to do it to every single face. I wanted some gaps. So again, this extrude is only running on this group here. And that group selected is the group that I created with this random selection here. So I created a selection, a random selection. I extruded only those pieces, and I extruded them by this value that I randomized. And then I just add some UVs and some materials to the sphere on the inside, and then the major part of the UFO there. And then I merge those together. So I basically have this inset sphere like that. And then I have my kind of basic UFO. I could go on and do tons more work to that, but that kind of gave me really quickly all I needed to create this UFO animation and bring it into Unreal, do something cool with it. So just wanted to highlight how simple it can be. And you could obviously, if you spent more than the half an hour that I spent fiddling with that, you could make something even more detailed. There's just some simple cleanup stuff after that. I fused the points, added some normals to make sure that the shading works. I cleaned up after myself, deleted some of those attributes that I don't need anymore. Then I pushed it out with an output, a ROP output there. The ROP is a render output, so that's another type of a render operator. It's another type of operator that just deals with exporting stuff. Cool. So that is some procedural modeling and a useful example of how quickly you can do something in Houdini. So let's talk about USD for a second. Let's have a little look at what USD is all about. So very briefly here, we've got our kitchen scene, which I downloaded from Pixar's website. It's freely available. So you can download this kitchen USD scene. This is it in Houdini 19. And then below here is it in Unreal Engine. And very, very similar. You get the same kind of view of all your objects. This stage is the same, whether it's in Houdini or Unreal Engine. And I'll show you this in a second. But yeah, basically, this allows you to be able to operate between these two programs almost instantaneously using a file that's external to both of them to be able to talk to both of them. So you can make changes, and there's so much more to it than that. You can override things in one. You can just take a little chair here from this scene, move it a little bit, and just save the difference, save where you moved that chair to, without having to save the entire scene and ending up with tons and tons of scene files everywhere that are out of sync. So this really allows you to work together a lot more effectively. So yeah, for layout, the things that you can do are to import USD assets from libraries. You can create USD assets very easily with Houdini. You can basically end up building your own pipeline or building a very effective pipeline to work with other people. USD is the idea of it is that you can pull lots and lots of information in from individual files, reference them in like you can in Maya, but it's in a universal scene format. It's like with Maya's scene format, proprietary to Maya. You can only reference Maya things into Maya. With this, you can reference in things from all over your pipeline. You don't have to push them all into this one monolithic scene file. You can reference in tons of objects. You can add layers on top of it to override and push things in at any stage in the pipeline. And it's becoming very widely adopted. So it's really, really useful to learn it. Most of the major tools, including Maya, Blender, Houdini, Unreal, they're all going for it. And also lighting, it's very, very good at containing lighting information, which traditionally scene formats were not very good at containing lighting, and cameras, and also animated geometry, like caching, kind of taking over from Alembic in that sense, being able to bring characters in, character information, character animation. So super powerful. And being able to, as you can see here, we built this lighting setup in Houdini, and then we're now able to bring it into Unreal and use the same lighting setup. So I actually developed it in Houdini and then used it in Unreal. So the scene with all the changes, all of these adjustments and movements were translated very simply into Houdini. So let's jump in, have a quick look at that. So I'm going to move over here to my USD stop. So I'm going to jump into this LOPnet. This is just allows us to go into USD like that. Very quickly, this component builder, which is very simple to access, this enables you to build USD assets, which can be quite hard to do if you don't use Houdini, to be able to build your asset library. And you could do this and convert your whole asset library procedurally using TOPS or task operators. You can automate your way through all of this and convert all of your assets. So that's where I'm again talking about punching above your weight. So you can basically do the work of multiple people as one person. But creating a USD asset is just as simple as going to our USD model assets tab here, and we'll go component builder. Just lay one of those down, and it lays down a bunch of nodes here. And this is what you need to be able to build your own USD asset. I'm just going to delete that one because I've got this one on the left here. So yeah, so anyway, I'll just leave it there. So this one on the left here, we have the node network that created a USD UFO asset. So I want to make this UFO that is already been built in my other context. I'm just referencing it in here. I'm just dragging this in, this UFO asset from where I created it outside of this network. I'm bringing it in here, dealing with the materials, and then at the end here, this is telling me where it's going to save it to. So just very, very simple. You can build up expressions to tell it where to put all of these assets and drive those with task operators so that you can automate all of this. But you could also type it in manually here if you want. But once those are set, this is then, if when I hit save to disk, this is going to do exactly that. So if I jump over to um, my scene here, we will check out. Okay, so it saved it into this USD folder here. And as you can see in this assets folder, I've got a UFO folder. So it made all of these things for me. It split the object up into all of its components that USD likes. So there's a payload and the major part of the geometry, and then this kind of header. And if I take this USD file now, if I wanted to say put it into Unreal Engine, very simply, I can just come in here, I can import it, I can just go to my UFO scene like this and drag it in. So dragging that in, it's going to say, where do I want all this stuff to go? I'm going to say yes to it going there. I'm just going to skip past some of this stuff. But yeah, some options to do with importing the USD right there. And we'll just import it. And now inside my UFO folder in static meshes, UFO, static meshes. As you can see, I've got my basic shape, my basic UFO shape, which I can drag into my scene here. And I'll just bring it over here and make it closer so we can see it. But there we go. There's our UFO that's come in from Houdini as a USD asset. So very, very simple to be able to do that. And then another thing which we can have a quick look at is if I jump over here to this kitchen scene. So I'm now referencing in this kitchen. It's in a different coordinate space. So let me just go and set that to Z up. 1 second. Okay, so kitchen. It's our free kitchen from Pixar. So with this, I am going to go into a different mode up the top here. Instead of build, I'm going to go to Solaris. Solaris is the name for the USD working context. And take a look at this. So here we have the kitchen set, the Pixar free kitchen set in Houdini. We've switched to our Solaris context, and we can see the stage down here in the bottom left. And what I can do after bringing this in as a file is I can start adding things. And when I save these things out, they're only going to save the bits that I've added. It's not going to save the whole kitchen. So if you like brought a bunch of geometry into another DCC and then did some things to it and then saved it all out again, you would save everything you brought in plus everything you did to it. This is just saving the differences. So I'm adding these extra lights in, and these are just going to be what gets saved afterwards. this node here means that I can actually duplicate. This is going to grab one of these chairs. I can do some simple operations to that. I can duplicate. I can start moving these chairs around and doing simple layout with them. Then this layout node here allows me to bring assets in. I can bring USD assets. I can, in this simple case here, I just used these Cheerios and scattered them on the table there. So yeah, moving on from that, I can now render this out to a USD file and bring all of those changes in. So let's just jump into Unreal 5 again, and we'll just take a look at this kitchen set here. So I've actually done this already in this USD scene here, but you can see this stage down here. It's very much the same stage as we were just looking at. So I can basically bring this difference in. I just saved all these differences out where those chairs were into a very, very light USD layer and bring that layer in. You can just add an existing layer here, and then we now have our differences. So I can turn those differences off, but because the differences actually brought in lights, when I turn that off, that's going to turn the lights off as well. So I'm just going to turn that layer back on that I brought in, and now it's bringing in all that exact lighting information from Houdini that I had in Houdini. So this exact scene here with all of its lighting and all of those changes with all the Cheerios on, it's not bringing in the entire kitchen, it's just bringing in those differences. So now I can see all the Cheerios on the table. I can see my lights in there. They're facing in the right direction with the right intensities. You might have to tweak the intensity a little bit depending on your setup in Unreal. But this allows you to be able to manipulate all of these things. And you can bring this kitchen in very, very quickly. And a couple other cool things that you can do here with your, just say one of these objects here, with this chair here. We loaded this chair in, but with USD, you can actually have several different chairs. So for this case here, we've got this one chair, which is chair B, but I could very easily just switch that chair back to chair A like that, and be right down the other end of the pipeline, just decide, oh, I didn't want it to be that chair, and just swap it there. You don't have to delete it, bring a whole new chair back in. So yeah, I'm oversimplifying the amount of things that you can do in here, but no, it's just so powerful to be able to work in this way using USD. And as I said, Houdini is extremely powerful at manipulating USD, creating USD, changing it, and working with other people in it as well. So we're going to get a little bit into some procedural rigging and motion now, using this new tool set called Kine Effects. And two major areas I would say was one being rigging and the other one being motion processing. So bottom here, we've got this procedural rigging example, so showing the squab model that you can bring in that's free with Houdini. And at the top here, something from Mixamo coming in. So we'll take a look at those in a second. But yeah, thinking of procedurally rigging things in SOPs. So we're using geometry to actually create joints. And we can do mocap processing, motion retargeting, procedural rigging, as I said, motion kit bashing. So some of the things that used to be able to just only do in Motion Builder can now do in Houdini procedurally and not manually. You can live link straight from a mocap system into Houdini. You can live link straight back out straight into Unreal or somewhere else. Yeah, super powerful. And as it says there, all of the SOPs nodes are available to you, so you can do wild things like create deformers and run joint systems through them, and do all kinds of cool, crazy stuff. So yeah, let's bring in Houdini again, and I will just switch back to Y up. and we'll jump back back up to this level where we're in SOPs again, but I'm just going to switch the context again to build instead of Solaris so that we're back in the main SOPs layout for being able to work on geometry. Okay, so very simple example here. Let us take a look at, which one should we have a look at? Let's look at the rigging one first. So um, yeah, here we've got the squab, very simple. Um, to bring that in, it's already in Houdini. You can just go find some of the test geometry and bring in a squab. That's it. So then we're running that through a Boolean, which just stops there from being any intersecting geometry. A few things here that we'll do, we'll just quickly remesh it and to simplify it. And then this labs node, which is really, really amazing, I think, is this is taking that geometry and turning it into curves. So it's kind of using a volume to create all of these curves here. And if I turn on points, you'll be able to see they're quite complex, the curves. So not really something we'd want to create joints out of because there's too many of them. So I'm doing a resample to create less joints, as you can see there, and then doing a fuse to make sure it's all stuck together. And then we're just going to go through to sorting and making sure that these are all pointing in the right direction so that we can actually create proper joints out of them. And coming down to our skeleton node right here. No, this one is responsible for turning it into a skeleton. We go through this rig doctor node and onto our rig pose node right here. So this rig pose, so now we actually have a joint skeleton. We have a joint hierarchy. So if I click on this right here, this will show you the Python state. So you can see some of the operations that you can do in rig pose. And if I just bring up the parameters here, you can see that you can actually manipulate all of the joints here. So you can actually animate these joints at this point. These ones are all procedural, so these just have little expressions in them. They're just very, very simple expressions here to be able to procedurally animate and just add some motion. So they're just adding some rotation to all those joints. So I remember what I've done here. I started with some geometry. I haven't done anything manual here. I didn't build any of these joints myself. This was all done with the labs tool to create curves from the geometry, and then the skeleton tool to create a skeleton from those curves, and then cleaning up a little bit on the way. Now we can add some more interesting stuff here. We can add secondary motion to this. So this is not dynamic. This is not simulated, I should say. This is calculated. So when I animate one of those curves, it will animate all the other curves in secondary motion, all the other points in secondary motion after it. So it's kind of a cheap way of being able to get overlap with your animation. And we've done that to all of those tentacles at the end there. So now you can see that all of those joints have secondary motion applied to them. There's just some simple stuff going on with the tail, just some rotations. They're just very, very simple expressions. Nothing more than just a sine wave going through them just to make them oscillate, making them rotate back and forth. Very, very, very straightforward. So now we're bringing our skeleton all the way through this left line here. So as we started here with our skeleton, then we run it through bone capture lines, which adds some more detail in between there. We're going to use this tet embed. So we're taking the geometry from our process here, running it through this tet embed function so that our bones run through the geometry essentially. And then this bone capture by harmonic, this is basically skinning. So it's skinning the joints to the geometry, all procedurally. Again, this is something that used to be traditionally very manual process. This is all happening procedurally. I haven't done anything manual here so far. And running it all down to the bottom here through this bone deform. And the bone deform is basically putting it all back together again. So going from where we had just geometry and skeleton and an animated version of the skeleton. So this left line is just our geometry, then it's skinned geometry as we did here with this bone capture. Then the just the skeleton on its own, the rest pose, and then the animated version on the right here. And this bone deform at the end just brings it all together so that now you can see it's animating the mesh. And then at the bottom here, just turn points off so you don't see them. But yeah, they have a completely procedurally rigged and animated squab that I think that's really, really cool because I've rigged a lot in my life. And the fact that, yes, you may have to go in and tweak a couple of joints that are maybe wrong, but to give you this as a starting place, or just if you had tons of characters and you wanted to save yourself time, you could, in theory, procedurally rig all your characters there and then animate them as well. And this really did not take very long to put together. And then very simply, you can just render those out at the end. And just to show you that it could work on a different character, this one right here, we have the rubber toy. And again, it's just the same principle, the same procedural mechanism to make that rigged and animated as well. So two different models there, and you could automate all of this and make it loop through a whole load of characters and bring them into your animation without having to rig them all. So I think that's pretty cool. Then I'm just going to show you another really quick one here. So this example right here, this is bringing in, so from the top up here, we've got our FPX of a Mixamo character that's downloaded from Mixamo from the internet. So this is not got any animation in it, it's just the skinned mesh of the character there. Then a couple of animations that we brought in. So there's these two animations. We've got a walking animation like that and a dancing animation like that. And we want to stitch these together. So the first thing I wanted to do was stop the walking from actually walking along. So I want to freeze it. So we're using this extract locomotion here, and that actually keeps it in place like that. So instead of it walking forwards, it's just staying still in one place. Then we create these two motion clips from it, which, as you can see, kind of looks like onion skinning there. Then we can take these two motion clips and create a motion clip sequence, and then it's very hard to look at it like that because you can see all the frames. But then if you create a motion clip evaluate, that brings it all back together again. And we've got these two, if I just click on that one. So we've got this walk, and then it blends in to the dance. So this is all done within this motion clip sequence node. So this will allow you to create blends between them. And hopefully they will keep evolving this into something more like the story mode in Motion Builder, but it's relatively simple to be able to blend those together. And then, yeah, really, really straightforward to go back to Unreal 5 again, right here, to bring this character into Unreal Engine. So I think in this folder here, I have a little sequencer. So I can just scrub through the timeline You can see that I just brought that FBX character in. We can now see the animation happening in Unreal Engine. So yeah, so very, very powerful what you can do there. And another really quick example, I'm going to take this one right here. So with this particular example here, so we have this dance animation. This is the mannequin that I exported from Unreal Engine. So from the top here, just going to go back to basics. Okay, so we've got our mannequin animation that's just come raw out of Unreal Engine. And then the second one here that we have is this Mixamo animation. So two different characters there. So first thing that we want to do is do this rig match pose. So I wanted to match these poses together as best as I could, so that I can apply the animation from one totally different character onto this character. So use this rig match pose. You can adjust and tweak all of these joints in the skeleton. Then we want to do map points, which is basically just drawing these lines very visually and easily between the two characters. So you can map one joint to the other from one character to the other, and then run it through full body IK. So this will kind of solve one onto the other, basically, without having mapped every single joint. This full body IK will allow you to map one skeleton onto the other one. And then we have this rig pose, which I can add more tweaks or animation to. And then at the end there, we've now got our Mixamo character animation on our mannequin skeleton. So you now see that the mannequin is dancing around like the Mixamo character. And the really cool thing with that is that because you've got all of these nodes that you can do things in between here, you can very easily do stuff like mirror the animation or just mirror the animation from the arm or batch process 2,000 animations from one character onto the other. You can live link this straight into Unreal Engine or live link it straight from mocap and do cleanup through the process. You can clean the animation as it goes through and then batch process it on the way out. And then you could do anything that you want from SOPs within Houdini to this motion because this is all geometry. So you could run it through some, I think I had a silly example of that here somewhere. Maybe it's not here anymore. Anyway, but you can essentially run it through a noise function, a noise filter, or any kind of deformer and make the skeleton do weird, fun stuff. So anyway, lots of cool things to be done there and very, very exciting area of Houdini, I think, for being able to process tons of animation and use all the amazing libraries that are out there, the animation libraries. So and go through a quick example of some simpler effects work. So what we are talking about here is vellum. So with vellum, we have the ability to create particle systems, cloth, fluids, grains. The cool thing is that all of these systems are unified, so you can have water splashing off cloth or things dropping into dynamic rigid bodies dropping into containers of water. It's not necessarily as good for doing giant ocean sims and that kind of thing, but it's much, much easier to jump into and use to create some simpler effects work. So let's jump into Houdini again. So we're going to go over here to this example here. So for this quick example, I'm just going to show some basic cloth. So here we have the simple grid, and I'm going to do a quick remesh on it to improve the geometry for deformation with cloth. I'm going to put some UVs on it, and then over here we have a sphere. So my cloth grid on top, I want to drape that over the sphere. So I'm going to run that geometry for the cloth through a vellum cloth node, or vellum constraints node set up for cloth. And then we're going to run the sphere in there as a constraint as well. So just geometry and constraint. And then we're going to run it through a vellum solver. And I just go back to the beginning there and then run the solver through, and you'll see what happens to it. So it's just draping that cloth over the sphere there. Very simple example of what you might do with cloth. Probably more realistically, it would be some clothes or something like that. But yeah, similar idea. You bring your character in, set the cloth up using this system, and with very few nodes here, you can set up. This is just as simple as going to Vellum, say Vellum configure cloth, drop that down. It's going to give you this Vellum configure cloth, and then you're going to create a Vellum solver and Vellum solver. There we go. And you're going to wire those two things together like that. That's the middle part of it here, and then you just hover over these, and it says vellum geometry. So put the cloth geometry in there, and this one is collision geometry. So put the thing you want it to collide with in there, and that's basically all that was done here. So much simpler than some of the other systems. Maybe not quite as in depth, but you can do most of the things you want to in here, and it's just way less setup to be able to do some of this stuff. So then at the end you can you can export all of that geometry out. Another very quick example I'll give you here. We've got a, sphere again and a grid. I like grids and spheres. So we've got this little, we're just going to make some fluid fall down this slope right here. Okay, so we've got our sphere, which is where the fluid's going to come from, and then our grid, that's what it's going to drop onto. So vellum fluid node, that's going to give us these balls here, which are going to represent the fluid. And then our solver brings it all together. So if I wind this back and just play that through, it's going to simulate. So they have that water from that sphere just splashing onto the ground there. And that looks kind of cool, but you've got a lot of control over that. So say I wanted to make it more gloopy, I could crank up the viscosity and then turn that back again. We'll run that through again. And now hopefully you should see that all kind of glooping together and sliding down a little bit more. But yeah, so it doesn't take any more time really than that just to set those up, which is kind of new in Houdini. That was a lot more painful before. And you can always make it more painful if you want. Jump into DOPS, have tons more control. But yeah, so that is a couple of quick examples there with just using Vellum to do some simple effects work without the headaches. All right. So what do you do next if you want to learn about this, if you want to take this further, if you want to get into Houdini? So a few things. Obviously, you need to get some hardware. You need a computer to run this on. Software, as I said, Houdini Apprentice is free. Indie's very cheap. And use that if you want to export geometry, because you can't really do that from Apprentice. But it's freely available at sideeffects.com. Go get it today. I would. That's how I started. Just downloaded it and started playing around with it and became very confused. And then went and asked somebody to tell me what was going on. So then you need to learn the skills. Obviously, Side Effects has got an incredible amount of free learning material on the website. That's really great. There's a load of great forums in Facebook and Reddit and all kinds of other places on the internet where you can find out great information from people who know what they're talking about and a bunch of people who don't know what they're talking about. But there are lots of information out there on the internet. So yeah, some great YouTube channels. I love the work that Matt Stella does and CG Wiki. The Timer guys are really great. Then there's obviously university. You can go to university. And then there's also online schools that will teach this stuff. So some of the challenges with learning Houdini, obviously, as I said, it's got a fairly steep learning curve if you're trying to go at it yourself. The online free resources are amazing, but sifting through them can be difficult. Some of the information can be out of date. It's very time consuming. If you get stuck in the middle, there's nobody to ask except the forums, and you get a kind of mixed response on those. Some amazing people out there who are very generous to their time, and then a lot of other people who have opinions that aren't always correct. And universities are great as well. I went to one, but they take a lot of time and money to go through. And if you just do you want to get this stuff quickly, that can be a bit of a problem. And then there's online training from industry professionals. And coincidentally or not, as I said, we are a school and we teach classes in Unreal and Houdini. We focus on mainly those two areas from virtual production and CG generalism. So if you would like to come and join us, I'm going to go through an opportunity now for you to be able to do that. And what we have is an 8-week immersive program to learn Houdini from beginner or intermediate level. It's going to go through all of the things that we looked at in actually show you how to do them. I know I kind of whizzed through a bunch of those, but we're going to go much more in depth into each one of those areas and teach you from the basics from the beginning what Houdini is, how it works, how to understand it, how to troubleshoot it, how to connect all the pieces together. So we meet twice a week in person. It's all taught live, so you can stop and ask questions when you get stuck. I am the lead instructor at the moment for this class. As I said, I've been using this program for years. I've taught it in universities for quite a long time. We're going to have a teaching assistant to help in the background and help support you throughout your journey over the 8 weeks. We have some video content and all the course upgrades, all the course platform upgrades you continue to get forever. We have an active forum for support all throughout the week. We have project downloads. We bring in guests from the industry who can add their opinions and flavor, and they're all people who are at the top of their game. They're all talking on various different aspects of the curriculum that we're going to go through. And then there's support options for afterwards. We have a placement department. We have alumni groups. We have all kinds of ways that you can keep being supported after the class. And the cost for this program, bearing in mind that it is all live taught, it's also recorded. You keep the recordings forever, but it's all live taught. It is $2,997 US, and that brings to a conclusion my webinar for today. I hope you've enjoyed it. I hope you learned something from it. I hope you got a little bit more excited about Houdini. I think it's really coming into its own, and just with all the things that are going on in CG and virtual production, it's tending towards liking generalists more, where before people wanted specialists a lot more. Now people are asking for generalists more and more. And this tool, as a generalist, I can tell you, having used it for years myself, not so much in the world of highly complex effect simulations. That tends to be effects artists, and this course was not really for those people. But as a generalist, being able to process tons of geometry, make really cool things, make really cool effects that that are really great for commercials and other areas, being able to process tons and tons of heavy geometry in a way that just other programs struggle, they can't. No, being able to batch process things, being able to automate things, being able to build tools without having to code. There you can get into the coding here for sure, and we'll go through that. We'll go through Vex and some of the ways that you can actually code. But the great thing is here, you can actually build tools without needing how to code. I think it's one of the most strong powers that it has. So I'm going to go through the curriculum briefly. Week 1, we're going through Houdini Foundations. We're going through what proceduralism is, the user interface, how to find your way around it. We're going to demystify all of the contexts and operators that we talked about, and we're going to get a really good solid understanding of what data is in Houdini and how it makes cool looking stuff coming out the other end. It's not all just about spreadsheets. This is about making cool stuff come out the other end of it. But you need a good understanding of how it's very different to other programs in order to be able to do that. And my mission has been to simplify the way to learn this tool because it's quite hard to learn. So that's what this is all about. It's demystifying it, simplifying it. And week two, we're going to go even deeper into that, but we're going to get slightly further ahead. I'm going to talk about things like wrangles and vex, and those are the ways that we can actually build our own deformers and really, really just get into how to process geometry. And yeah, it's week three. We're going through USD and LOPS, doing layout and understanding how to work with USD. Week four, we're going to go more in depth into environment building and how to do layout in SOPs, how to build landscapes, how to do really amazing environments. The Matrix example is something that if you have a small team and a bit of time, a small team who's very good and a bit of time, you can build something as complex as that massive city procedurally. But the principles of how that's done are going to get taught here. Week five, we're going to go into effects. We're going to talk about Vellum and how that works and how you can do effects in a more straightforward way. Week six, we are going to go through the motion stuff. So we're going to go through the Kine effects, retargeting, motion processing, motion kit bashing, and we're going to bring most of these into Unreal at some point. We are going to, in week seven, we're going to talk about the output because that's an important part of what to do next. In general, you're making this stuff in Houdini, but you're probably going to put it somewhere else. People do render things in Houdini as well, and we'll go through that. But this is all about how to get stuff out and be able to put it into Unreal Engine through USD, through effects going out and in using vertex animation textures, which is a super fast way of being able to do complex effects from Houdini, bringing them in to Unreal Engine. And then wrap it all up with rendering. And we're going to talk about Karma within Houdini, and we're going to talk about Unreal Engine 5, which is a renderer as well. So that is the curriculum that we're going to go through in the 8 weeks. If you are interested, I'd love to have a conversation with you about it. Please feel free to reach out. We're very accessible. I am the instructor for this class currently. I'm available for conversations about this. So if you would like to, please click the link, book a call with us today. And I look forward to hearing what your goals are and seeing what I can do to help. Thank you very much for listening, and I will see you all somewhere soon on another webinar.